Okay, so we're going to use Google Colab to basically find the height over the radius when the specific gravity is set to 0.8. So we're going to plot this out and then allow the code to return the number to us. So first we're going to import numpy as np, and we're going to do this from the scipy dot optimize and import the root scalar. And this is basically used to, the optimization is basically used for providing functions and for root finding, curve fitting, other things like that. So as far as the next line, we're going to go import the plotly dot graph, and this for graphing the objects. And then we're going to import plotly.io as pio. Okay. So we're going to add a new code, and then from there we're going to go define HR, and this will be equal to np linspace, and this is for our plot. We're going to have it go from 0 to 1, and then it'll be in increments of 10. So for each return, it'll give us 10 returns between 0 and 1. And then we're going to set the specific gravity as SG, and we'll set that equal to our equation that we found in the first half. So go np dot the arc cosine of 1 minus HR. Then we'll subtract np dot square root and go 2 times HR. Then do that to the second power. Close that parentheses, and then we'll go times 1 minus HR and close that one. Close another. Seems like we have one too many. Yeah, two too many. 1 minus HR, and then divide that by np dot pi. Okay. So we're going to add another code. After defining those, we're going to now go to figure, set that equal to go dot figure open close parentheses, and then we'll go figure dot add underscore scatter, and this will be for the numbers at the x and y axis. So x will be set to HR, and we'll set y as our specific gravity. Okay, close that parenthesis. Okay, it's looking good. So figure dot, now we're going to update the layout to a color, and we're just going to go with this one. So template equals and we'll go the dark. Okay. Cool. All right. Next, we are going to go. We're going to update the layout. These numbers are set to place the plot. So we'll go. set that equal to 400, and we will set the width equal to 500. And here we're going to go ahead and return and set the x-axis underscore title and set that equal to h over r. And then we're going to do the y-axis title as our specific gravity. We'll go ahead and type it out to make it easy to understand. Not necessary though. Okay. And we're going to go ahead and put a comma there, and then go underscore again, go x-axis. Then this will be for the increments. So we'll go x-axis tick 0 or not. We'll set that equal to 0, and then our x-axis, then the increment of our ticks will be 0.2. There we go, nice and easy. And now we're going to put our titles in. So set our title as specific gravity of floating cylinder for go side caret BR. That way we can return it to that line under, so it's not too long. Varying height, say it's H, to be specific above water level. Okay. Looks good. Alright, we'll do one more line for here. Oh, I think I messed that up. Yeah. So let me go back. This should be right there. Okay. Looks good. Alright. So now we're going to go title underscore x. We'll set that equal to 0.5 and center it. Okay. Go ahead and close it up here and delete these. That looks bad. Alright. So that looks good. We don't need this line. Okay. Alright. So that should give us our plot. We're going to go ahead and make our next line of coding. We're going to define our function of HR. So go, here it is, HR. And go ahead and return our equation and plug in 0.8. So we're going to go turn 1 minus, and then type in our equation. Could just copy and paste, but where's the fun in that? Minus np dot square root 2 times HR. And then HR. Then yeah, double close those, and then we're going to divide that by pi. Okay, and then gonna plug in our 0.8. Cool. All right. Now let's go ahead and go result and set that equal to our root scalar, and then our function of f, and then bracket is equal to 0.1. Or 0 and then to 1. bracket. Okay, close that, and then result. Okay, and then one more code. We'll go. Actually, that's it. Yep. So let's go ahead and run this and see how it turns out. Okay, so it looks like I messed up in the beginning where I did not actually finish typing this out all the way. So, or I actually, did I miss a line? Okay, so I don't know why I put, I meant to put plotly dot graph underscore operators. Okay, so that will make more sense. I think that should work. All right, let's X this out. Everything else looks good, I think. All right, play that. Let's run this one. Okay, so this one is also a little messed up. Okay, so let's try running this again. All right, it looks like that worked. We'll go ahead and run the graph. Okay, so we have our graph and the axis labeled, and let's go ahead and return the number. So yeah, so here we see when the specific gravity is set to 0.8, we return the height over the radius as this number, 0.50814. So that is the height over radius when the specific gravity is set to 0.8.